Okay, welcome to playlist of heatmap, video number 6. Yeah, so this video intend to cover the detail feature, and then since there are too many detail features, so I'm not gonna get into very detail. So for whatever that has been covered before, I'll just skip it. Yeah, in this heatmap generator, there are a few features. The first help and guide on the left panel. Yeah, this is similar to the layout guide. Yeah, but you can see all the information that if you get lost, you can find some guidance here, and there's a policy down here. Okay, and yeah, we have described how to select the number of AP and then control this AP's position, height, operating frequency band, and transmit power. Okay, so this is the table here, and then we have introduced this last time to generate heat map, but we didn't introduce is this one. Okay, this is the drop down pull down menu. Yeah, you can pick a layout ready for you to generate heat map. Yeah, if you don't want to generate layout yourself, you can just pick whatever layout that is available to you. And where are this layout coming from? Yeah, this layout are from a data set by a research team of Alibaba. Yeah, so I just use their layout data set, yeah, to generate all this. And after that, you can generate heat map as before, and then you'll see the heat map. Okay, and then for today, yeah, I have worked on the heat layout of my home. Yeah, the place I live. So I just pull that in. Okay. So this is the correct size. The background is gone. Yeah, because background is not important here. So I basically draw all of this in half an hour. Okay. So it's pretty fast. And then as before, I can just adjust the location and the parameter. Okay. For example, yeah, this is actually the true location that internet enter my home. Yeah, and it's in the corner. So when we just bought this house, and then all my kids complain they cannot receive the Wi-Fi signal, and then so let's see what is going on. So you can see it's a mess. Basically, yeah. This is my kids' room, so they are like very weak they are receiving very weak signal. And then eventually I put another AP. I put another AP here. This is the living room. And then try again. Okay, so it becomes much nicer, right? All the indoor area are covered. Yeah, this is the master room, and this is the bedroom of my two kids, and this is the living room. And so if I put here, so everything is covered except for this place. This is a toilet, and the remaining function is the 3D structure. Yeah. So other than this, we have covered almost everything in the video number 3, I guess. Okay, so it looked pretty complicated. Fine, if we only want to see the furniture, I can pick this one, and this is the furniture. Everything else is gone. Everything is gone, and then you can use the right click of the mouse to move it. And so if you just move it to a position that you want to get back to your original position, you just push this framework and you'll come to the center. And then you can see like wall only. You only want to see the wall. You don't want to see all the furniture. And this is the wall only. You can see the windows only. These are all the windows. Okay, but if you want to have everything back, then you can hit this load all. Then everything will come back. Yeah, you can room in, room out. Yeah, so
这个3D 图除了可以看到这些动景之外，
可以这样。
还可以得到什么样的资讯？还是说就是看它在3D 的高度跟位置这样子？
Danny is asking, what is the purpose of this 3D view? Of course, the first important thing is the human sense. You can sense that the 3D look really look like this. And then the second important thing, this is not just only for fun or for your view, your sense of the environment. Yeah, this is actually what get into the ray tracing algorithm that I'm using now, the Sherna RT. Sherna RT is actually a 3D simulator. Yeah, most simulators nowadays are 3D simulator. Yeah, but for convenience, I use SVG. SVG is a 2D like graph format, and then I have to convert it into 3D before I can run the Shannon RT. And then so this is the end product. So I didn't create this for fun. I create this as exactly the required input format for Shannon RT. That this file is in the format of PLY.
So does the heat map generation time change significantly with the number of APs or layout complexity?
The heat map generator will take some time, and the time it requires depends on several things. It's increased linearly with the number of AP. Yeah, just as I explained last time. If I have 5 AP, I have to run it 5 times, and then get 5 heat map, and then take the maximum function of this 5 map to generate the final heat map. And then the second thing, it will depends on the number of ray, the AP emit. And then right now I just pick the maximum value, which is 1 billion. So this is a huge number. So it's a bit slower because I picked the maximum number. Yeah, but there's still some stochastic noise everywhere. 1 billion is obviously not even enough. Of course, the number of items in the layout will also matter. Yeah, because if you hit nothing, then this ray will die away. If you keep hitting something and then bounce back and forth, yeah. So I would say it's probably the complexity will increase probably more than linear. Yeah, I think if you have like double the number of items, it will increase the compression more than double. Yeah, so yeah, but I'm not quite sure about that. So let me wrap it up. Yeah, so for this heat map generator, there are a few features. They are like help and guide to tell you where the information you probably missed when you don't know how to proceed. And then there's a drop down menu for you to pick the layout that you do not have draw layout yourself. And then you can hit this button to generate a heat map. Before that, of course you need to pick the number of AP and adjust the parameter, and all the parameters are in this table. And then yeah, we have this 3D view that can provide you the human sense of the environment. And then this is exactly the format that I use to run the Shannon RT ray tracing heat map simulator.